Hi everyone, we have the 20th class for differentiation of calculus, but this is the second video or the second class or the second example for implicit functions. But differentiation in general, this is the 20th class. We want to find dy dx given x squared plus xy plus y squared equal to 7. I go again, how do we easily identify implicit functions when the function is all about x and y? When y has a power other than 1, whether the power is 2, whether the power is 3, whether the power is 4. Once you see this one and you want to find dy dx, consider implicit function. When you have a term that comprises or consists of xy, consider implicit function. So what makes this one an implicit function? Y has a power other than 1, greater than 1, then there is a term that comprises xy. So this is an implicit function. So there is a slight difference how we differentiate implicit function from what the normal functions. As usual, x squared will give us 2x if we differentiate it. Of course, we are not discussing how basically we differentiate because we are now at the 20th lesson. So we did a lot of basic differentiation. Okay, so 2 times 1 is 2, x minus 1 is 1. Now let us pay attention here. We want to differentiate xy. Here, let us differentiate x. Here, let us differentiate y. We want to differentiate xy. Here, whenever you have x and y combined, the same term, you differentiate it twice. The first one, if you can choose to say, well, let me start by differentiating y, later I differentiate x. Or let me start by differentiating x, later I differentiate y. But when you have a term that comprises xy, you differentiate x, you differentiate y for that particular term. So let's say here we differentiate x, here we differentiate y. Now let's go how we differentiate x. You all know that differentiating just x, the result is 1. Differentiating 2x is 2. 5x is 5. So xy is like having 1x, 1. Xy is like having 2x2. Xy is like having 5x, 5. So I just want to say xy is like yx. So if it is like yx, 1x, 2x, 5x, yx. So if 1x is 1, 2x is 2, 5x is 5, yx is y. So this is y. I hope you get this one. Okay, how about differentiating y? If you are differentiating y, assume there is no x. Or the same thing goes, differentiating 1x is 1, 2x is 2, 3x is what? Is 3. Here we are not differentiating x. We are differentiating y. I'm only using x because it is so often. Okay, so if we are differentiating 1x, 1, 2x, 2, 3x, 3. So if we are differentiating xy, what do we get? We just get x. Or if possible, let me change the explanation because there is another way to explain it. Let me just change the explanation. Just be patient because I wanted to get it once and for all. When the term comprises xy, you differentiate x, you differentiate y. So xy, xy. But we want to differentiate x. Later we differentiate y. So if we are differentiating x, let us assume there is no y. We assume there is no y. So if we differentiate x, what do we get? We get 1. And when you assume there is no y, you can bring it later, 1y. I think this explanation is better. Now I want to differentiate y. If we want to differentiate y, let us assume there is no x, we only have y. If you differentiate y, what do we get? We get 1. But the x we assume it's not part of it is this one. But mind you, the fact that you've acknowledged this one being an implicit function, whenever I differentiate y, you add dy dx. This is the only difference about it. Whenever I differentiate y, what do you do? You add dy dx. So now we want to differentiate x. So we assume there is no y. We only have x. So if you differentiate x, what do we get? We get 1. The y we assume was not part of it. It is this one. What do we differentiate here? X. No problem. Differentiate x is 1. The y we assume it's not part of it is this one. Plus. Now we want to differentiate what? Y. We want to differentiate what? We want to differentiate y. We assume there is no x. So if you differentiate y, what do we get? We get 1. The x we assume is not part of it is this one. But don't forget that differentiating y, you must supposed to add dy dx. And we all know it's not necessary to use 1 with a letter. So plus differentiating y squared. 2 times 1 is 2. Y 2 minus 1 is 1. We differentiated y. We must add dy dx. Differentiating a constant is 0. We want to find dy dx. So let us collect the terms containing dy dx. This term is x, dy dx. This term is 2y, dy dx. The other terms go to the other side, minus 2x minus y. But we need only dy dx. So we say dy dx. Dy dx takes away this leaving x. Dy dx cancels this leaving 2y, which is what is common there, minus 2x plus y, because minus times plus minus, minus times plus minus. We need only dy dx. So we divide both sides by this. X plus 2y, x plus 2y. So dy dx is the negative of what? 2x plus y over x plus 2y. So thank you for watching. Do not forget to follow, like, share, and comment. See my next video.